You know how you get a text alert from the delivery driver before your food arrives, so your hungry kids stop freaking out? Vonage does that. You know how you get a text alert from the delivery driver before your food arrives, so your hungry kids stop freaking out? Vonage does that.
Good afternoon, everybody. Hopefully you had a nice lunch. So we might wait a few minutes. So this talk is for build a mobile robot using MakerPy and CircuitPython, presented by Idris Zainal Abidin. So let's get started in about 1 minute or so. Wait for some people to get streaming in. Right. So in meanwhile, I'll just introduce Idris. So Idris has been playing with microcontrollers for more than 10 years. He loves technology, robotics, and Python. I think his code is a headache. You only have a little bit of knowledge for it, but I think he will have lots of interesting to share with all of you. But before we get started, I think we have some administrative notification from the organizers. So they do remind you to ensure that you refresh your schedule constantly to see the any latest updates. So yeah, if you have just been referring to an old version of the page, do refresh it constantly. But in all of that, I will actually now invite Idris in here to maybe have a short intro, and then we can start presentation. Okay, over to you, Idris.
Okay, thank you, moderator. Okay, assalamualaikum and good afternoon, everyone. So I'm Idris from Citron Technologies. Citron is a company that focuses on electronics for education, for development, or maybe for industry. In other words, we are focused more on the hardware, or maybe we can call it physical computing. And we are not a software company. Okay, my initial intention actually is just to share about CircuitPython. Okay, about CircuitPython. Since the theme of this year's conference is related to robotics, so I decided to make a simple robotic application using CircuitPython. Okay, so this is an example of the robot that I have built just for tutorial, because every week we produce a tutorial in our website so that the customers or maybe the audience know how to use the electronic stuff and how to build itself. Okay. Alright, so this is my education background. I went to school in Johor from Standard 1 to SPM. Then I furthered my study at UiTM Shah Alam for diploma and degree in electrical engineering. I started working at Siri Bukit Jalil as an engineer. And of 2013, I worked at Citron Technologies until now. I'm not an engineer anymore. Currently, I work together with the marketing team. So maybe I need to put a disclaimer here. I'm not a Python guru. I just learned through Google and YouTube. So if there are any mistakes from me, I apologize and please let me know. Okay. There are 7 topics that I will try to cover today. I hope I can cover it all. Okay, we start with introduction to CircuitPython, and then I will use the controller board MakerPy RP2040. Next is how to get started with CircuitPython. Once we set up everything, then we can go for CircuitPython essentials. Okay, starting from topic 5 until 7, we will start to focus on building the mobile robot. So it will involve programming, electronics, and mechanisms. In case I don't have enough time, I will give priority to topics 1 to 4, because you can find the tutorial about the mobile robot in our tutorial page to cover topic 5 to 6. Okay, so we will go to the first topic. Before I directly talk about CircuitPython, maybe we can highlight again what is Python. Okay, I believe most of the participants today have a Python background. Okay, as we know, Python is a computer programming language often used to build websites and software, automate tasks, and conduct data analysis. The point I want to highlight here, we normally use Python in a computer that runs operating system like Windows, Mac, or Linux. Okay, and then it can be used by developers and non-developers alike. It means this language is very beginner friendly. It is easy to read, easy to write, and of course easy to learn. And then we can deny it was one of the most popular programming language among developers in 2020. Okay. Next is, what is MicroPython? Okay, still not CircuitPython. What is MicroPython? So MicroPython is a full Python compiler and runtime that runs on the microcontroller. Okay, it was founded by Damien George in 2014. He is a physicist in Australia. If you still remember what I mentioned before, we normally install and use Python in a computer that has an operating system, has OS. Okay, so why not just use this regular Python in the microcontroller? Okay, first, microcontrollers only have a tiny flash and RAM compared to the computer. Okay, and then second, regular Python implementation is called CPython because it is written in C. So Damien George re-implementation of Python, he called it MicroPython, and he emphasized on low memory use. Okay, currently MicroPython supports PyBot. So PyBot is actually designed by himself, and he launched the Kickstarter, I think around 2014 or 15 or maybe 16, I'm not remember. So this board is based on STM RP2040 Cortex M4, and it runs at 168 megahertz. So if you compare among microcontrollers board, this one is quite powerful. Alright, and then it also supports popular expressive boards such as ESP8266 and ESP32. Okay, and then the latest one is Raspberry Pi Pico. So Raspberry Pi, as we know that Raspberry Pi very popular among the single board computer community. So Raspberry Pi also makes MicroPython as one of the official language for the Raspberry Pi Pico. So Raspberry Pi Pico is actually the first microcontroller board produced by Raspberry Pi. So it's not a computer, it's a microcontroller. Alright. Okay, now we will talk about CircuitPython. Okay, so one of the CircuitPython developers named Dan, okay, he is trying MicroPython and thought it was great, but later he realized that the way of MicroPython is oriented toward professional programmers. In other words, it is not really beginner friendly. So CircuitPython is a fork based on MicroPython. It's a derivative of MicroPython. Means everything good from MicroPython will be maintained, and they add or they improve features and make it easier. So it focused on beginners, education, and if you want to build a prototype, it is very helpful. Now it supports more than 200 boards. For example, Raspberry Pi Pico or any boards based on the RP2040 chip. And then SAMD21 is a Cortex M0, SAMD51 Cortex M4. And then chip from Expressive ESP32S2, but it does not support ESP8266 and ESP32 like MicroPython. So why? I will explain them later. Okay, so of course there are lots of other boards, including NRF52840, Microbit V2, and etc. Okay, now we will try to compare between CircuitPython and MicroPython. So this one I bold the CircuitPython means the advantage for CircuitPython over the MicroPython. The first point is USB disk drive. So when you plug in the CircuitPython board to the computer, it will be detected as a USB disk drive. Okay, all files are listed there and you can easily manage them, like to rename, delete, or move to the folder. So MicroPython is not like this. And then second, it will auto reload when the file is saved. So this one maybe later I will show the demo, quite easier. Third, it has a consistent API across all boards. Okay, this feature is not emphasized in MicroPython. And then there are a lot of examples and support from CircuitPython. So the community of CircuitPython is quite active. Okay, you can visit the website later. Then you can see the updates from the CircuitPython is quite fast. Okay, another good point is most CircuitPython libraries also work on Raspberry Pi computers via the Blinka library. So for beginners with one language or API, you can write a program for a microcontroller and a single board computers. So this not just a Raspberry Pi. It supports a few single box computer that runs Linux. So you can visit the website. It has a few lists of the single box computer. Okay, so how about MicroPython? So if you are using MicroPython, you have access to advanced APIs such as interrupts and threading. And you can have a complete PIO API. PIO API is one of the features in Raspberry Pi Pico. So this one is quite advanced for advanced user, where you can customize the signal on each pins, okay, each I/O. And then, of course, you should use MicroPython if you are using existing MicroPython code. For example, you search for tutorials and the tutorials provide the MicroPython example, so of course you need to use MicroPython. Okay, so that's all about introduction to CircuitPython. Next, we will go to the MakerPi RP2040. Okay, let's see a few photos here. So you can see this is a RP2040 chip, the first microcontroller from Raspberry Pi. Okay, at the back you can write your own name here at the white space here. Okay, so this board objective is to simplify robotics with Raspberry Pi RP2040. Okay, it supports 4 servo motors and 2 DC motors, and it has 13 status indicator LEDs for GPIO pins, 1 piezo buzzer with mute switch, 2 programmable push buttons, 2 RGB LEDs. It is called NeoPixel, and actually there are more features for this board. I just highlighted a few. This is the board layout. Okay, I will start from the top left. So there is a VIN terminal here, VIN terminal. You can supply from 3.6 volt to 6 volt, and then this is a single LiPo battery connector, power LED, on-off switch, okay, debug port here, micro USB port. Okay, micro USB port, you can use it to charge the LiPo battery. If you are not using the LiPo battery, you can use it to power up the board and also to program the board. Okay, then a reset button to restart the program, boot button to enter the what we call RPi RP2 drive, where you can flash the CircuitPython UF2 file. So this one also later we show the demo. And then there are 7 groove ports, okay, 2 RGB LEDs located here and here, 2 programmable push buttons, piezo buzzer with mute switch, GPIO status indicator LEDs here, motor test buttons. This is like a quick test, so you can verify your motor is actually working without programming it. And then servo ports, there are 4 channels for servo, GP12 until GP15. And then last but not least, the DC motor terminals together with motor status LEDs. Okay. Alright, so Now let's get started with CircuitPython. So before that, maybe I can try to answer a few questions here. Maybe can highlight the question from Mr. Valdez. MicroPython, is MicroPython low level compared to the CircuitPython? Okay, that's okay. Later we'll try to answer at the end of the presentation. Alright, so let's get started. So this actually this board already comes with CircuitPython, and it has a default code runs. So the default code actually to test all the components at the board, like LEDs, buzzer, and then to check the ports, servo ports, and then DC motors. Okay, but I would like to start from scratch now. Right, so maybe I can share my camera. Where's my camera? Okay, this is my camera. This is my mobile robot. So MakerPy RP2040 at the top. Okay. So now I already connect the USB. Okay, I already connect the board to the computer through a USB cable. So in order to make the computer detect the board, you need to turn on the robot first. Turn on the board. Okay, so I will turn on. So when I turn on, it will be detected as a drive, USB drive. So in this drive, you can see there are a few files, but I would like to highlight the important files first. So actually only have two. First one is a code. This one is in Python format, code.py. So this code will automatically run when you turn on the board, or when you make a changes, like you edit the program and you save the file. So it will automatic reload and run. Okay, and then the other is like lib folder. Okay, so in the lib folder, it will have a few libraries. By default, actually it don't have any libraries. This one, as I mentioned before, that it comes with the few standard files to test all the features on the board. So it already include a few files. So actually I can remove this all, and then later how to get started from scratch. Okay. Alright, so to get started, you can go to the CircuitPython website. And I already put a link at this photo. So when I click it, it will go to the CircuitPython website, and under the MakerPy RP2040 product. Okay, so in case, of course, you don't have the link, right? So you can just search the CircuitPython. Okay, this is the main page of CircuitPython, circuitpython.org. So, and then you can click on downloads. You can see here it's displaying 235 boards. Okay, they have a lot of boards here. So just search MakerPy RP2040. Okay, so it will go the same page as I showed before. So the important thing is you need to download this file, UF2 file. Okay, so this is the latest version, 7.0.0, release candidate 3. So even it's still unstable release, but okay, still okay, you can try. Okay, so I click it and it will download the UF2 files. Okay, now I show in folder. Okay, this is the file. Alright, so to flash UF2 inside the MakerPy RP2040 board, you need to enter the RP2 drive. Okay, for now you can see it is stated CircuitPy drive. Okay, so it is not this drive. So how to enter the CircuitPy drive, how to enter the RP2 drive? Okay, so you can see the boot button here. Press and hold and press the reset button once. Okay, so it will enter the RP2 drive. Okay, now I can copy and paste the UF2 file inside this drive. So I just drag the file so it will copy. Alright, so it will automatically like restart the program and it will enter the CircuitPy drive. Okay, so then you can check the boot out text file here. So just open using any text editor, for example Notepad. So you can see it stated Adafruit CircuitPython 7.0.0 release candidate 3. Okay, and then this is a bot. Okay, so means you have a latest version of CircuitPython, and then next we will try to write a program on it. Okay. So I will go back to the slide. Okay. Text editor for CircuitPython. So because your board is detected as a drive and there are few files, so you are free to use any text editor actually to edit the file. For example, I can even edit the code.py here using the notepad. Okay, but of course if you want to write a long program, this is not suitable. Okay, it's not convenient. So there are few recommended text editor for CircuitPython. The most recommended for beginners is Mo Editor. Okay, Mo Editor, you can search through Google, type Mo Editor, and then you can download it. Okay, so click download, and then you can based on your operating system, you can download the latest version is 1.1.0 beta 5. Okay, so I already download and install on my computer. So I will open it. Wait, yeah. Okay, so this is a Mo Editor software. Okay, and then you can load the file. So normally we will just load the main file or code.py from the drive. So click load and go to the CircuitPy and then choose code.py and open. So this is the default code I mentioned before, comes with the board to test all the LEDs, buttons, and then servo motors and DC motors. Okay, so I will show you. Maybe I can try. I press GP21 button. Okay, you can see the melody. So when I press the GP20, all the digital I/O status light up, and the motors and the servo. Actually, servo is to test the angle lah. But this one I use the different types of servo that can rotate continuously. Okay. Okay, so this is a default code. So I want to show how to get started from scratch. Okay, so this is a drive, CircuitPy drive. So either you just delete the default code or you rename it. Okay, once you rename it, it will not run any code because the CircuitPython will automatically run any file that name code.py. Okay, for example, I just rename it to default. It's called code. So I change it, so it will not run any program. Okay, so maybe it's a good start from scratch. So I will close the code, and then I click new, and then I save on the same drive, and I name it as code.py. Okay, save. So now the board will automatically run this code, but because it's still empty, so no code lah. Okay. All right. Maybe we can verify a few, so we can go through the layout of the mode editor. So you can see the first icon is a mode. You can click it, and then actually it supports a few other boards, like even the MicroPython also supports using a mode editor, and then a standard Python 3, okay, and then web. So you must choose the CircuitPython, okay, and then new to create a new files, load to load files, save files, serial. Okay, we click on serial. So serial will display the CircuitPython REPL or the status of the program. Okay, so I click the serial. You can see auto reload is on. Simply save files over USB to run them, or enter REPL to disable. Press any key to enter the REPL. Use Ctrl D to reload. So if I press any key, it will enter the REPL. Okay, so for example, I want to write a very simple program, print hello world. So you can see the output is hello world. So actually it already runs in the board, the REPL. So when you in the REPL mode, you need to press Ctrl D to reload the program again, in case you have already write a certain code here. So Ctrl D will start to reload and run the program. Okay, so if not, if you just write and save, it will not auto run. So you need to exit the REPL, and then it will run the program, run the code.py. So I press Ctrl.D, so it exit the REPL and run the code.py, but code.py is still empty, so no program will be run. Okay, so next, just a slide. Okay, so when everything is set up, okay, your board can be detected in the on your computer, and then you can you have test the REPL, so it has a response, means the CircuitPython already run on your board. So now we will go through the CircuitPython essentials. So this one is more to beginners on how to write the program. Okay, so actually all these examples is prepared by Adafruit. You can go to this link. It covers on the pins and modules, built-ins, digital in-out, analog in, analog out, audio out, MP3, PWM, servo, capacitive touch, internal RGB LED, NeoPixel, dot star, UART serial, I2C, HID keyboard and mouse, storage and CPU temperature. So I will not cover all, so I have highlighted a few like pins and modules, digital in and out. For analog in and servo, I will show on the robot itself. So I have connected the servo motor, and also there are a sensor. So for digital in and out, I can show a component at the top of the boards like LEDs and button. Okay, so let's try. So you can click this link, go to the or maybe you can just search CircuitPython Essentials, so you will directly go to this website. Okay, this is prepared by Adafruit. Maybe I didn't mention before that CircuitPython is founded by Adafruit, one of the company in New York that like Citron, so selling the electronics stuff and microcontroller, all that. Okay, so you can click one by one and read, go through. So for example, CircuitPython's pins and modules. Okay, for example, this is when I download the UF2 file. You can see here it stated the built-in modules available. So when you flash using this file, it already comes with all these modules. Okay, all boards have a different, because not for example, board that have more flash, it can equip with more modules. Okay, for example, this is quite many, okay, for modules, and then you can later you can try to check what these modules offer, okay, through this CircuitPython pins and modules. Okay, for example, I try to show the example. I enter the REPL. Okay, so I import board. This one is quite important lah. Every time we try the new microcontroller board, we don't know how to write the pin numbers, so this one is quite useful. So I write there port. So for example here, so this is a name of pins that I can write on the program. So like A0, A1, A2, A3, buzzer, GP0, okay, and then M1A, M1B. This one is referred to the motor, and then voltage monitor, port ID. So this one is quite useful. Okay, and then maybe next you can apply it on the modules also. Okay, you can just go through all the examples here. All right, so built-ins. So maybe we can directly go to the digital in and out. So this is a example. You can just copy and paste if you want a fast result. Okay, so maybe I can write a program, Control T. So I exit the REPL. So I will write a simple program to control the LED. Okay, so import port, and then import digital I/O. Import time. Okay, So we need to define a pin first. For example, LED equal to digital IO dot digital in out bracket port, and this one is the name of the pins. Okay, for example, I want to control GP, maybe GP5, GP5. Okay, GP5. So board.gp5, and then you need to set it as output. So the direction is output, digital IO dot direction dot output. Okay, and then while true, this is very standard to do the LED blinking. So LED dot value equal to true to give a signal high to the pins, and then time dot sleep to delay maybe around 100 milliseconds, and then turn off the LED equal to false. Okay, so when I save the file, okay, you can see the GP5 is flash. So you can see the others LED light up. So because it still maintain the previous state from the default code. So maybe I try to turn off and turn on again. Oh, okay, sorry. The GP4 is because it's connected to the. There are few GPIO connected to sensors, and this one sensors lah. Both is sensors. Okay, so it's light up. So currently I just control the GP5. Okay. Okay, so that one's how to getting started, and how to on your first program, first CircuitPython program, and how to run it. Okay, once you know how to run the program, then the rest is more on the skills to write the programs. Okay. Okay, so I think we still have time here. Okay, so I will continue to the quite advanced. Where are the slides? Okay, so digital in and out. Oh, the buttons. I forgot to show the buttons. Okay, this one is just for the output. Now maybe we can try add another one. Buttons. Button equal to digital. I just copy and paste. And then just change the GP. What is GPIO? So buttons, for example, GP20. So I just use the GP20 and change it to input. Okay. Don't need to set its pull up, because in the board already comes with pull up resistor. So just set its input. Already okay. So if button dot value equal to false. Okay, because it is active low, means when you press the signal is low. So this means I press the buttons, so I will light up the LED. Else I will turn off the LED. Else. Alright, so maybe we can test it. Oh, actually I cannot use the GP5 because I have connected to the sensor. Okay, but if you don't have any connection, you can use any LED. So I think I changed the LED to 16. Okay, 16. This one I don't use any connection here, so I will control the 16. Right, so save. So I try to press a button. Wait, this is quite normal when you want to demo, it's everything not working. Can set value when direction is input. Oh, okay. Sorry. Why are there? Oh, sorry. Silly mistake. Alright, so you can see the LED on the GP16. So when I press, the LED will light up. Okay, so that's how we control the LED, and we read the signal from the buttons. So these two we call the digital in and digital out. Okay, so next, okay, we have another 15 minutes. I will try to cover it. Thank you, my Sarah. Alright, so for analog in and servo, I will cover on the robot itself, because I have connected the servo. So this is the actuator I use, micro servo 360 continuous. Wait, okay. The features and spec, the operating voltage is from 3 to 5.5 volt DC. So operating voltage is one of the important spec that we need to take a look when supply the power. Okay, and then the rotation is a 360 continuous rotation. It's not a normal servo where you can control the angle. So this one will continuous rotate. And then rated torque 1.6 kilogram per cm. Materials, plastic gears and plastic enclosure, and this is for wiring, orange for RC, red for VCC, and brown for ground. So no worries, because in the pins here, servo pins here, we already arrange the pins so that you just slot in the servo ports. So just make sure the brown is connected to the ground or minus, okay, and then the orange to the signal S. Alright, so I connect to the GP12 and GP13 for servo, and then okay, so we can try to control a bit on the servo. So the way to control the servo is actually same as standard servo, where the center angle is about 1.5 milliseconds, and then the most right or 180 degrees 2 milliseconds, and the most left or 0 degrees is 1 millisecond. So the way to control the servo is still same, just for continuous servo motor it will change the degrees to the speed, okay, to the speed. So 0 degrees means the most fastest on the counterclockwise, for example. Okay, then the 180 degrees is the most fast for the clockwise. Okay, 90 degrees will stop the motor. Okay, for example here we'll stop the motor, and then you just control the width of the pulse here. But in the CircuitPython, it already comes with a library, and then it's quite easy to use. So maybe we can try. So try here under CircuitPython Essentials, you can see the servo, CircuitPython servo. So you can see what you need to write, what you need to include. Okay, so Adafruit also create a library for Moto that including the servo. Okay, so it will require an additional libraries, Adafruit Moto. So how to include the library? So actually you can get the library from the website and just copy paste inside the lib folder. Okay, for example, I already put it here, Adafruit Moto. So where to download? Okay, go to the CircuitPython website, and then you notice the libraries tab here. So click here, and then okay, there are bundles libraries. So it depends on what version you use. For example, if you are using version 7, then you need to download this bundle. If you are still using the previous version, 6 point something, so you need to use this library bundle. So just download it. For example, I download it. Okay, show in folder and extract all. Oh, it takes quite some time. It's quite big maybe. Okay, just it's okay, just let it extract the file. So then you can find the library and you copy and paste and include it in the lib folder. Okay, let's try to write a simple coding. So for example, here I will okay, pwmio Adafruit Moto, and then wait there. Okay, I maybe I can share the link. Share the link to private chat. Okay, maybe the admin can share the link to the audience. For those who are asking the tutorial, so this is a tutorial, a very short tutorial where how to assemble and then what parts required and the sample program. And then actually there are two sample programs. The first one only line following robot, and then the second one I add the function of the object detection. Okay, because I think I don't have enough time to explain all. Okay, maybe I will start to answer the few questions first. Okay, MakerPi RP2040 don't have any 5-volt pins. Yes, it don't have a 5-volt pin. So all the pins on the groove is a 3.3 volts. So yes, you need to use a 3.3 volt sensors or modules to interface with the MakerPi RP2040. So in case you really need a 5-volt, you can consider this one, another types of board that supports CircuitPython. This is a MakerPi Pico. Okay, so this one have a 5-volt options. Alright, next, hi Idris, do you have the tutorial steps for this mobile robots? Yes, I have shared the link. Okay, I think the admin already share on the comment. Later maybe can put in the description this link. Okay, so sorry because I don't have, I think, enough time to show everything.
We got about maybe 6 minutes more. If there's no further questions, maybe you want to try to finish this demo, then at least people can see.
All right. So maybe I skip a bit to directly show the application. So in order to use the example code, actually you need to, this one is okay lah. Sometimes the indent is not correct when displayed here. So in case to be more safe, you can view raw, so you can copy this sample program. So maybe I just copy all the sample program here, copy and then paste. Okay, save. So this sample program includes the how to control the servo motors and then how to read the sensors. Okay, how to read the sensors. You can go through the sample program line by line. All right. So for example now, okay, you can see actually at the bottom here, I put a line sensor, make a line, and then it able to detect a line position. So the important thing when developing the mobile robot, you need to know where the position of line, and then you need to control the motor to align to follow the line. Okay, so I need to calibrate the sensor. So the program also including to calibrate the sensor. I need to press button. So actually it's try to calibrate the sensor. This one I already connect the LiPo battery, so it can be portable without the USB cable. So let's say I try to show. Okay, you can see when assume this one is the middle, okay, robot in the middle. So when the robot slightly to sway to the left, you can see the speed of this motor will slow and stop. So actually we will try to get the robot to the center line. So the same goes to here, this motor will stop. Okay. So when we talk about the line following robots, it include a few fields to combine. For example, electronics, and then the mechanism, how you design a body. So this one I just designed using Fusion 360 and print it using 3D printer. And then actually you can just use a standard DC motors here. Why I use the servo 360? Because it is easy to design. Okay, you can see the shape is like a square, right? So it is easy to mount the motor, and then Um, as long as it can move, it is enough for me lah. Okay. All right. Then the program also including the apply the what we call the PID method. So this one is quite advanced for control. So it will include some formula, and then in order to make the robot move smoothly to follow the line. Okay. So I don't have time to show one by one from motors to the sensor, but you can go to this example code. Actually, it's already include all the servos, even the piezo melody through a piezo buzzer, and then the sensor to read the analog signal and then to calibrate it. I have created a few functions how to calibrate the sensor. Okay, so you can try to do more with CircuitPython on the microcontroller. Okay, what is the name of the MakerPi with 5 volts? So we have two types of MakerPi. So this one on the robot is a MakerPi RP2040. This one is a MakerPi Pico. No, okay, MakerPi Pico. MakerPi Pico means it comes with this one. MakerPi Pico. It comes with Raspberry Pi Pico. So you can see the green board here is Raspberry Pi Pico from Raspberry Pi. So yeah, this one we designed from the chip. Okay, just put the chip and a few components to support the chip, and then we designed to have a more on robotic applications, robotic or motion applications. Okay, I think I don't have any more to share.
Okay.
If you have,
Yeah. Thanks a lot, Idris. Yeah. So if you guys have any more questions, we can definitely hang around here another 5 minutes. But the next session should probably be starting now in the other channel. So I'll be on this channel for maybe in the next 5 minutes. If you guys have any last questions, yeah. So very good demo. I might I don't know too much about circuits, but yeah, it looks approachable enough that you and I can try this out. So yeah, thank you very much. So those who want to proceed to the next session, don't forget to update your schedule. There should be a link in there. We'll be on this channel for another maybe 5 minutes. If you have any final questions for Idris.
okay,
Thank you again very much, Idris. We'll stick here for the next 5 minutes.
Okay, thank you. So CircuitPython is still new in Malaysia, and previously, because I quite active on the microcontroller, so as you know, we will normally use Arduino. Okay, Arduino is very popular in Malaysia. So when CircuitPython comes, I really like it because it's very easy, and even Arduino is already easy enough. But because we have experience to teach the beginners, so I can feel that CircuitPython is another step of easy. Okay, it's quite more easier than the Arduino. Okay.
So would you say Arduino actually we can skip Arduino and just go straight to CircuitPython?
Yes. Because the CircuitPython have the advantage of the Python itself. Python itself is a very easy language to learn compared to the C, right? C++. So that's a point. And then the way CircuitPython present the way to use it, so that one is another advantage. Very easy to use, straightforward. Yeah.
So once you have some mastery, then do you move to Python, microcontroller kind of stuff? That means skip Arduino straight away, and now you can technically stick with Python even for lower level kind of things. And once you get the confidence. Okay.
For example, like when we learn all the Arduino stuff, and then we want to move to the single board computer like Raspberry Pi, most of the examples in the Python. So you need to learn a new language, Python. Okay, like even for those that are familiar with the programming language, any language is actually quite same, just on the logical, on the APIs difference. But for beginners, it will learn a new language again. So if you start from the Python, maybe MicroPython or CircuitPython, so you have an advantage to go to the next step, to the computer level, to start do the application using Python.
Okay, thanks very much. I think I didn't see any more questions. Again, thank you for spending your afternoon here. Very fascinating. Looks like Jega will be trying it out. So thank you very much, and we'll see you guys in the next session. Okay,
thank you.
We'll be stopping broadcast now. Thanks.